Hi everyone, hope you're doing well today. We are not actually doing a second take of this. This is our first take, obviously. I'd like to welcome Lee Hamoud today. He is a great friend of mine and a wonderful, wonderful Unreal Engine developer, and he will, surprise, surprise, be talking about Unreal Engine today. Lee started working on games as a solo developer and is now a lead developer, because he's Lee, uh, on a game called Soar, which is a really, really wonderful flying VR game. So, Lee, if you'd like to introduce yourself a tiny bit more and tell us a bit about Unreal Engine and, get us into the talk, the floor is yours.
Okay, cool. Well, thanks for everyone for coming in. My name's Lee. I've been making games since like 2015, 2016. I started using Unreal when it was Unreal Engine 4.7. That back then it was very difficult to find resources for it, but it was still a lot of fun. It looks completely different now. It's like a baby has grown into a monster. A bit of an admirable monster, but also a bit of a scary monster in a good way. I made a couple of solo games. I've made my own company. I've made my own studio. We've showcased a couple of my solo game that I made called Psychoversity, a couple of events. Got some nice exposure for it. Got some nice I don't know, awards, I guess, for it as well. And that I started doing a lot of not freelancing, but a little bit of like a contracting work with a lot of different talented studios as a 3Cs, like camera, 3Cs as in like camera control character and Unreal, obviously, and a couple of other studios as well. And now a few years ago, we started making we co-founded a new studio across, remotely, and it's a VR game, a studio that was working on a VR game, and it's a VR game called Soar for basically flying in VR in a one-to-one New York City scale. So that's literally the pitch of it. You basically fly as a Superman in a one-to-one New York City scale. It's right now out in early access. It's multiplayer, so you can play with friends, you can play with not so friends, you can shoot them, you can make friends, and fly together and enjoy your time. And it's out on early access. So if you can afford it, buy it because we need the money. Anyway, um, that's the bit of a small intro. Do we like? I guess we'll start with the talk then. All right. So I'm gonna screen share. Screen share here. Bring the slides here. So the talk is gonna be a bit of mix of a couple of things. So I'm going to bring this over here. Okay, cool. So a bit of a disclaimer on the talk. We're going to be doing a bunch of various things. It's going to be a bit of a workshop. It's going to be a bit of a core explanation over things. It's going to be a bit of an improvisation, a couple of other things. I'm going to be talking about blueprints. I'm going to be talking about material shaders. I'm going to be talking about version control. I'm going to be, yeah, what else? Yeah, there's a lot. So I'm going to be talking also about debugging and blueprints. We're going to be touching a couple of other things, like, for example, like Niagara's, even C++ if you want to. If we have the time, we can do C++ a little bit. We're going to be going a little bit core into blueprints here, just because it can help a lot. And I've started with Unreal. I spent like basically 5 years doing blueprints only. A couple of my solo games were purely blueprints. So it is very powerful. It is very useful. And once you understand its limitations, you can work around these limitations and you can make amazing stuff out of it. And I've seen many games and many people have done it with just blueprints. So I'm going to talk in a little bit of a disclaimer as well. The structure of the talk, I already talked about this. We'll talk about basically what I'm going to be doing as well. I'm going to be like, it's going to be a bit of a funnel. We're going to be touching a lot of beginner stuff, but we're going to go a little bit deeper on some trivial, some things that it's good to know. You don't really have to know them, but it's good to know. And then one more thing, I'm going to be sharing the slides and the source code of what we will create at the end as well. The slides are not really like talk slides. They're just reference guides. There's going to be a little bit of a lot of links in there because I want you to get you started with Unreal. I want you to get started with the different tools that you have as well. So there's going to be a lot of resources here and there that you can just go in and understand how things work. Now, one more thing as well is that the most important note is that Unreal is a massive, massive engine. There's hundreds of people working on it. It's been for the last 5 years, and they're working on it for the next 5 years. So there's something for you if you don't like one part of it. If you don't like blueprints, you're probably going to like something else. If you don't like let's say, shaders or Niagara or like PCG, or like there's so many things that you can just go in and explore and make something good out of. And you can get specialized in something. But also at the same time, Unreal is the kind of engine where you can't know everything. You can't know basically all of it, right? I've been using Unreal for the last 8 years, and I'm like perhaps 50% there, even maybe 80% kind of like, what does that tool do? So, and that's completely fine. And that's completely normal because it's an ever expanding engine. At the end of the talk, I'll also like show you a link of the world map of Unreal if you're interested in that. Okay, so that's the disclaimer. That's the core stuff. I mean, that's the disclaimer stuff. Let's talk about programming. Let's talk about blueprints. So with blueprints and C++, in Unreal, there's two ways to program. There's a couple of third parties, but essentially there's C++ and there's blueprints. Now, it is important to mention that the C++ in Unreal Engine isn't actually C++ native. It is C++ syntax. It is C++ everything else, but it is not purely C++. It's not purely native C++. What does that mean? It means that there's a lot of libraries, there's a lot of macros, there's a lot of APIs, there's a lot of stuff that Unreal, more like Epic Games, does for you in order to make your life a little bit easier, such as garbage collection. You hear a lot about memory and whatnot in C++ and C type languages, like about memory and whatnot. Well, Unreal does garbage collection for you. It does reflection system for you. It does a bunch of other things for C++, so that it becomes literally in its own Unreal C++ as its own separate thing that is built on top of C++ native. Now, it doesn't make it any. It doesn't make it easier, but it doesn't make it any. It is still difficult, and that's why there's also blueprints. Now, blueprints, hopefully we shall make Skyrim easier to develop, right? And that's where blueprints come in. Maybe we'll see. So blueprints is a visual scripting language of C++. It's literally C++ wrapped in nodes. Now, when I say not wrapped in nodes, it's wrapped in basically nodes that you can connect to. We'll talk about that a little bit. But the more important thing to understand from that is that blueprints is not meant to like completely replace C++. Once you get to know Unreal more, once you make Unreal games 2, 3 years, 4 years later, you will start understanding and seeing a lot of patterns of like studios making a lot of the hard code, a lot of the under the hood code, a lot of the robust and foundations code made in C++, and then everything on top of that made in blueprints. And that really depends on the scope of the game. Yes, I did a bit of a contradiction. Like I said, like you can make blueprints game full. Yes, you totally can make games fully in blueprints, but there are some caveats, and you're going to get an idea of those caveats basically throughout the talk. That's the important bit. Now, should I switch to this slide or should I go into blueprints further? Okay. I think, you know what, let's do this slide first, and then we'll touch on this slide, and then we'll talk about blueprints further, or like we'll start demonstrating. So Unreal core class hierarchy, that's something that's been existing on Unreal for as long as it exists. All the way from Unreal 1, Unreal 2, you'll find this hierarchy on Unreal 3, Unreal 4, and Unreal 5 now. That is pending to change in the soon, but this is what we have right now. The reason why it's important to understand this core class hierarchy, because this will define how you can now approach basically creating classes and creating blueprints and creating what is this for and what is that for. Take a snippet of that if you want. We'll be sharing the slides later, but get an idea of how, take a look at it and get an idea how things are, because we'll be revisiting this in the future. But the key takeaway to take from this is that everything in Unreal, everything that you do, that is blueprints and the editor, there's some edge cases where it's not, but everything that there is inherited by something called, where is it? UObjects. Now you saw objects, but there is an additional term, which is called UObjects. Now UObjects stand for Unreal Objects, right? Everything else, everything in the engine is derived from that. It is important. It is good to know that. It's not important to know that if you're prototyping a game right now or you're starting out. It's good to know because in the future, once you understand things more, you will start like, oh my God, that makes a lot more sense. It took me some time to understand that on my side. All right. Now moving on, let's talk about blueprints. So I'm going to skip a few steps in Unreal. I'm going to skip the project creation. I'm going to skip the viewport and all that stuff. I'm going to jump straight into blueprints. And then later on, when we do a little bit of time in workshop, we'll jump back into like creating the project, version control of the project, viewport, and all that stuff. So with blueprints, this is what you will see if you are creating blueprints. And it's lagging a lot. That's perfectly fine because that's Unreal. Well, kind of. Anyway, so just a quick demonstration, we can create a blueprint class immediately here. Just like we talked about in the class hierarchy, there's a bunch of different classes you can inherit to. And these are them. We'll be talking about them in the future. But for now, I created a actor class, which is a type of those classes. One thing to mention as well is that because Unreal is old, it's also holding a lot of old programming patterns, such as inheritance. Inheritance is considered now like a bit of an older archetype of how you program things. And now actor is, for example, inheriting from ViewObject. That's something. Anyway, so before we dive deep into components and my blueprints and the taskbar and all the tools and all the fancy and overwhelming stuff, so I remember when I first opened blueprints, I was like, what the hell is even going on there? Before we dive deeper into that, let's talk about just basically the nodes themselves. So in blueprints, we have different types of nodes, as I would like to think. Now, some people might have different definitions. This is my personal takeaway on how I view the nodes here. You've got a few types of nodes. You've got, let's say, I'm counting them right now on my fingers. So 6. Yes, 6. So you've got the flow nodes. You've got something called impure nodes. You've got something called pure nodes. You've got something called event nodes. You've got something called variable and component variable nodes. And then also you've got something called arithmetic, which is a good way to demonstrate this right now. It's just arithmetic is basically arithmetic calculations. It's basically math nodes. Now, if you noticed that they're all color coded, you've got the whites as in, well, maybe not this one. The whites as in flow nodes. You've got the blues as in impure nodes. You've got the pure nodes as in green nodes, and they've got the event nodes as in green, red nodes. And then you've got the variable components, whatever the data type of the variable is, because if you notice, the data type is actually color coded as well, which is great for visualization. And the arithmetic nodes, they don't have color. So what's the name of the plugin? The name of the plugin is electronic nodes. I'll be sharing, that's going to be shared in the slide later. It's very useful. It's fantastic. I love it so much. It makes spaghetti life easier. So, okay. So we're going to talk about, okay. So event nodes and impure nodes, you notice that there's something interesting in them. You'll notice that, and also flow nodes. You'll notice that unlike the others, got basically something going on there, which is like a white triangle pin. And you notice that some of them have them on inputs and some of them have them on outputs and some of them have them both, right? And all nodes can have different types of like inputs and outputs and all of that. Now, the takeaway here is that this is called an execution wire. If you hover over it, it's called exec. Now, exec is basically your electricity to actually execute the functions that you need to run. So if I bring this here, I just copy it and then I place it here, nothing is going to happen, right? And if I do this as well, nothing is also going to happen, even though there is electricity happening between them. Imagine their electricity, right? Well, for every electricity, for every electric wire, we need a source or a power plant. And those power plants, in layman's terms, are basically the event nodes. Now, event nodes, they are marked by red. And event nodes, if you're coming from other game engines, you'll notice immediately, oh, event nodes, it's like update tick or a gameplay script that you can find in C#, for example. Yes. And event nodes are basically the power plants in order to execute the things that you need to execute to run the functions that you need. And event nodes can have a lot of different things. Event nodes can have event tick, you've got event begin play. You've got event collisions, which is not really a name, but it encapsulates the term called on actor begin play. Sorry, on actor begin overlap. I can overlap on actor end overlap. You got inputs. Inputs are events, so red events. And you've got basically like lifespan events, such as like what? Like on end play, which is also on begin play, right? Same thing. Life events, lifespan events, right? They have a lot of different types of event nodes in order to execute the things they need to execute. So that now, if I do this, if I bring event begin play here, now if I compile and I play, this will run and this will run afterwards. Meaning that now you need to, now that you've supplied it with event begin play is basically like, hey, when the actor starts existing, whether you've already placed it before level and you start playing start, or you've spawned it. When you've done that and an event begin plays, this is where you have like spawn system application, like such as the function that we've mentioned, and then launch character to the nearest point. This is, by the way, a custom function that we will demonstrate in a little bit and during the workshop. Same thing with event tick. Event tick is basically every tick, every single frame that runs the game. Let's say you have 60 frames per second happening. Every single, for 60 times in that 1 second, this code will run. Now, you'll hear a lot of misconceptions like event ticks are expensive, don't use them and whatnot. There are some caveats there, and there are some proven profiling measurements that sometimes it is good and sometimes it is good. And we'll be revisiting them in the future. Now that we understand, okay, well, you've got event ticks and you've got, event nodes, and then you've got impure nodes. You'll notice, okay, well, what about the ones that are like, without execution wires, right? You've got the pure nodes, which have no execution wire, but rather like just whatever output and input there is. And then you've got basically the component variables and whatnot. One more thing before I jump into that is that also the flow nodes are super important that you should definitely familiarize yourself with, because they will give you basically a sense of like what you can do. We will go through them as well in a tiny bit of a workshop if we have time, because it's already 6:30. So anyway, so the impure nodes, with the pure nodes that don't have any execution wires, if you've noticed, there are, they can be categorized in one single way of looking at them. They are basically data getters. That's what they are. You can get the player character, or you can get the player, get active location, get my Boolean variable, get my integer variable, get the sphere component. So if you noticed, these are data containers. All they do is give you the data that you need in order to do whatever thing you want in order to run the function that is an impure function to mutate whatever data you need. They don't mutate data. They only get the data. It's very important to understand that, because in the future, when you create your own pure nodes, you will also understand that you shouldn't also mutate any data inside of them. Now, you notice, okay, well, this is getters. Get this, get that, get data, get that. Oh, well, that is actually very now parallel to what? To the getter and setter programming pattern that is found in Java and JavaScript and Pythons and all these languages. First started out as a bit of a trivia. First started as a security check, but then now it's actually used as a good pattern. And you can think about them that way. Here, I'm getting the variables, I'm getting the data, and here I'm setting. Even though I'm not setting like spawn location, like the function itself is not called spawn location, whatever, spawn system at location, but I am mutating data, I'm setting data, and that's the biggest difference. Now, this is what you need to know in terms of like the different types of nodes that you've got there. For example, with additional more, arithmetic is something that you can like get yourself immediately familiarized when you play around with arithmetics. And you'll notice like, okay, well, I can just like calculate and whatever. Like, just remember that because it's an impure node, technically, whatever result is not being saved. You're only basically using it once for every time you're calling it. So if you want to save your results, you need to set the variable, which is you do it that way by grabbing it and by grabbing the my float variable and by setting. Or you can also right-click on any empty space in blueprints, and say, set my float variable. There we go. Now I actually saved the results of whatever calculations I did. Now, to revisit the context switch, this is called content browser. Yes, the context browser. Content browser is basically all the functions in Unreal exist in your at the top of your finger, kind of. But if you've noticed, if you click on any module or any like category, you'll notice that there's some of them are blue, some of them are green. Those are pure and impure functions. The reason, yeah, I'm not going to go deep into that because it's going to be a little bit confusing, but it's important to know, like, hey, if I want to set the actual location, I can just like right click on this and then type the actual location. There you go. Now you have a function for it, and now you can connect it to whatever you want, and bam, you also now can set the actual rotation. So it's very useful. It's very important. And there's the other tool, other than the electronic nodes, there's the other tool that I use for assist that has very good features inside of it. I'll be talking about that as well in the future. Now, before I talk about basically how you connect nodes and how you like view blueprints, is I want to talk a bit of something trivia, which is also going to be something that it's good to know. You don't really have to know, but it's good to know because it will also make you understand, like, hey, now I understand why blueprints is the way blueprints is. Which is funny because it's not exactly because there's a lot of different material node graphs in Unreal. There's the material node graph, there's the Niagara node graph, there's the control rig node graph, there's PCG node graph, and they all have their own way of functioning. They share a lot of things, but they all have their own way of functioning. And in Blueprint's case, it is important to know one thing for sure, which is basically, remember when we said everything is your object? Technically, like if you inherit everything from your object. Well, in Unreal, there are basically threads. And those threads, well, before I explain threads, I'm going to say this thing, and I'm going to let you ponder over it. Everything in Unreal, that is calculations on the CPU, so U objects on the CPU, so physics, geometry calculation, collision calculation, occlusion calculation, anything that you need variables to set, that is for blueprints, I'm not talking about anything else, but specifically for blueprints, they all run on the same single thread, which is called the game thread, which you probably heard a lot if you go a little bit deeper inside Unreal. And in Unreal, there's essentially 3 threads: game thread, draw thread, and game thread. And then sometimes there's something called RHI thread, which is, it's not a different thread depending on how you set up your project. But I'm not going to go into that. We're not going to go into deep any of that. Sorry, was that game thread? Sorry, that was render thread. Okay. And by the way, this is not important to know, but it's also good to know because now if I do this, if I go to the viewport and I type stat unit, just stat underscore space unit, you'll notice that on the other side, on the right side, you've got frame, game, draw, HIIT, GPU time, resolution draws, and primitives. You'll notice that these are actually the game threads, right? Oh, sorry, the threads that are used to render the scene, to computate the scene, to calculate all the physics and all the stuff that you need. Now, let's forget about these for a moment. Let's talk about the game threads for a moment. Everything in Unreal is on the game thread, right? Like in terms of blueprints. Well, imagine in layman's term, you are a person working on this thread or this sidewalk. Technically, you're gonna always be moving in a linear fashion. So you're never gonna be jumping unless, like, I don't know, like you jump. Just don't jump, just keep walking. Okay. And when you walk, because everything is linear, everything is also dissected into its own parts. Meaning, if I grab this, if what we were working before, like we were working with basically BP underscore GA actor, right? Well, BP_GA actor has something called event begin play, and then you go like what we said, spawn system location, right? That will actually function here, and then it'll move to the next thing, which is, let's say, physics calculation, right? And then it could move to the next thing, which is basically whatever, like whatever actor you make, whatever actor or like another calculation you do. The reason why it's important to know that, because on a micro level, this is the macro level. On a micro level, your sequence of events will also function in a linear fashion. So event begin play will start first. Play will start first. Spawn system. Sorry, spawn system is just like, just imagine it's a different function. It's any function that you can think of. Sorry, I took that a bit of too literal with that. Like any function. So let's do this. Any function. And then any function outside after function 1. So any function 2 and then any function 1. And now you'll understand, okay, well, everything is on a sequential linear pattern. Well, guess what? That also applies on how you do blueprints. Because in blueprints, you cannot have, for example, multiple, sorry. What I was going to say? Yeah. So in blueprints, you can have basically this linear fashion of basically node structure. So before I go do this, this is how things would play. This is how things would function. So let's say I event play. This will fire up, then this, then this, then this, then this. And it's important to understand that, because in the future, you will see, like, you'll come across a bunch of bugs here and there that doesn't respect that sort of linear constraint of what blueprints is, right? But then things can get interesting, because now you're kind of like, okay, well, I want two functions. I can have multiple inputs, right? Like, let's say on event begin play, event actor begin play, begin overlap, I do this, but on event begin play, I do that. So technically, you can have multiple inputs. And if you think about it in terms of lines of codes, it's literally like a line code after line of code after a line of code. But you can't have multiple outputs. You can have multiple outputs, but you can't have multiple outputs from. Oops, go away. Okay. You can't have multiple outputs from the nodes unless if you're using specific flow nodes, such as sequence. Sequence, you can actually do that. But technically, sequence isn't actually like multiple outputs at the same time. What's happening here is that it's actually going, hey, I'm going to execute all of this. And then once I'm done executing all of this, I'm going to execute this on then one. Then all I'm done, I'm going to execute the third and the fourth and the fifth. So it's still sequentially, even though visually it shows that you have multiple outputs. Multiple outputs, but it's still sequential. And that's something you just very important to understand. I use sequence in this case not because it's very super important to know right now, but it's also trivial in explaining how these things work. Now, that being said, this applies for event, for red nodes, or impure function nodes, which is the blue nodes. Well, let's talk a little bit back to the pure nodes. By the way, if you see this pattern, just before we jump to that, I know I'm jumping a lot between things, but there's definitely a lot to take in here. But it's also super easy once you understand it. Like blueprints is incredibly easy. So if you see this pattern, by the way, what's happening here is that just think of them like a completely separate lines, right? Like this is saying event actor begin play, launch character, set actor on the rotation, launch character. I guess we're just launching the character again, right? In this case, it's also happening the same. Begin play, spawn system location, launch character, spawn system, then launch character again, right? Whatever. But just imagine they're separate. They're not actually connected to each other because they come from different outputs to the same input. Yes, they come from different outputs to the same input, but they're not connected. As a matter of fact, what I recommend to the people that I sort of work with, the juniors that I work with, for example, I would recommend them, in this case, to actually separate them completely, because this will help in basically doing something that is basically a sin of blueprints, which is called spaghetti code. And spaghetti code is the kind of code where you see just lines all over where, hence why it's called spaghetti. You want to try and create not a spaghetti, like maybe try to create like a, I don't know what's the right term, rice, I don't know. But the point is, very bad joke. But the point is, you try to create the kind of thing where you can try to separate as much as possible. And as a matter of fact, in the workshop and after that, we're going to be doing basically, we're going to be actually turning a lot of these stuff into their own functions so that everything looks into one big node instead of like having like 7, 8 different nodes on top of each other. And it's crazy. But there's also some caveats there. So I'm jumping around a little bit. But before I jump around, I'm going to talk about back again to the pure nodes. Pure nodes, you'll notice something very interesting. You'll notice that pure nodes can have multiple outputs. We just said that we can't have multiple outputs. Well, yes, technically we can't. And what's happening actually still is like that. It's just blueprints, it's just visualized that way. But what you can't have in Unreal is sometimes you can't have multiple inputs. And in this case, pure nodes, most often than none, don't have multiple inputs. You can try. I think what I recommend from like to know whether you can have like multiple inputs and outputs, aside, I'm not talking about the execution wire. I'm talking about everything else here. I'll be talking a little bit about those in a little bit. But aside from the execution wire, sometimes you can have multiple inputs, like multiple like things happening here, and sometimes you can't. You just have to experiment and see. Like this is the nitty bit about blueprints. But you'll notice in this case, like, damn, okay, well, I can't just wait. Sorry. I can have multiple outputs running into different 4 or 5 different nodes. That's very true. But what's actually happening under the hood, which is again a bit of trivial, you don't really have to know it, but it's very important kind of to know it because it will help a lot in debugging in the future, which is what's happening here. Every time you connect into a different node, it's actually being called again and again and again and again. Only visually, it seems like it's being copied and pasted and like the same wire. It's like it's almost as if like the same electric pulse that's happening between the 4 different nodes. That's not the case. I know it's weird. Why would Unreal do that? Well, it's visual, right? They don't want you to worry about this stuff, but I do want you to worry a little bit about this stuff because in a trivial case or an edge case, I would say, because it's firing multiple times, you'll notice there's going to be something happening, which is this. I'm using the node getter, which is called, the pure function called random float in range. I'm basically asking Unreal, hey, Unreal, give me a range of float value between 0 to 1. All right, great, easy, right? Well, if I connect it to multiple impure functions, we said that it gets called every single time. And you will see that if I do event begin play right now, you will see that it has actually called multiple different times and has given me different values every single time as well, which could be so bad and so detrimental in bug fixing when you're like wanting to use a random fixed value, random fixed value, and then like having to reuse it again and again. In this case, it doesn't do that way. And you can think about it this way, mostly in every single pure function case. Like what's happening here, get player character. If I connect it 4 times with 4 different nodes, it is going to get called every single time it's connected to an impure function. So that's very important to know because in the future, it will help you in debug. Well, in this case, okay, Lee, what's the solution here? The solution is actually pretty simple. You create a variable, and let's demonstrate creating a variable over here. Let's say, okay, in the creating a variable, it's actually very easy. And the details panel on my blueprint on the left side, if you're using the default editor layout, there is something called, there's a bit of a tiny plus button next to the variables. And if you click on it, it'll create a variable. Then you can switch to whatever type you want. Remember, they're color coded, but you have booleans, bytes, integers, floats, all the way to transforms. And then you have structures variables, which is something you don't have to really worry about if you're like starting out. And then something even more advanced, not so advanced once you get the hang of blueprints, is object types. Now, all you got to worry about right now are like just the basic data types. They actually call them, like there's a specific programming term that I actually forgot what they're called. I forgot. I'll remember it later probably. In this case, we're just going to create a vault right? So we just created a float. And now it wants me to name the float. So let's say my float variable 2. The reason why I call it 2 is because we already have a float variable 1. We cannot have variables conflicting the name, conflicting with same similar names, even if they have different types, by the way. So now that I've come here, I can like now drag this, drop it, set variable, and then, sorry, I already did it before, but imagine I didn't do it before. Imagine it's empty. And then I'm just going to connect it, right, to the random float in range. Now it's cached in, it's stored into this variable. Now I'm going to connect it to the power plant, which is the event begin play in this case. Now I'm going to connect it to the print string. Print string is basically just a debugging way to basically know your values. We'll talk about debugging and blueprints shortly after. So now I'm going to do this. It's called 4 times. So I see the wire that's going to 4 times, but it's called 4 times as well. Now I'm going to play. And I'm going to see the results. And my results are, they're going to have all the same variable name. Sorry, the variable values. Sorry, the same value, which is stored in a variable, which is then fed into these functions that are pure functions, specifically print string, which is a debugging function. So that's the caveat that you need to know and understand about pure functions, impure functions, events, and all that stuff. I know it sounds a little bit like, bit of spaghetti in a way, but once we have the workshop, hopefully we'll get into, we'll see, understand like how things work together. It's very easy, super easy. All right, I minimized Unreal by mistake. Now I can find it. All right. One more thing I need to mention that is important about Unreal is that you'll hear the term, sorry, not Unreal, blueprints, technically Unreal, blueprints, is that you'll hear the term a lot called object-oriented programming, OOP. It is quite a controversial pattern, right? And in this case, it's used in Unreal because 1, Unreal is very old, and 2, you actually need to work with objects in games because you are working with a lot of instances. And what are objects? Just to go at a bit of trivial, objects are basically instances of a class. The class is what contains the functions, the variables, the stuff that you need. You don't have to know exactly all of that right now. I would recommend always to just watch a video, ask ChatGPT, watch it. Hey ChatGPT, just tell me OOP, yeah, whatever, and tell me, hey, in the context of Unreal, right? So what I need you to know though is in blueprints, you're always going to notice something that specifically in impure function, most of the time, if not all the time, half of the time, I'd say most of the time, something called target, like over here, right? Target here, got target here. I want to get more functions because I'm reusing the same functions more and more. Like let me get another function very quick, like move component too. Let me get this function. This is a good function that you guys are probably going to be using a lot as well. Move component too. This also has a target, but not exactly how I wanted to do it. Okay, let's get a function. Say this is static. Say get an actor function. Okay, set actor tick enable. Let's do that. Yeah. Okay. You'll notice that they all have target here, component technically here, target here, whatever, right? What I need you to know in this case is that when it says target self, it's basically saying, hey, where do you want me to run? Unreal is basically asking you, hey, where do you want me to run this function? On what object, right? And then in order to understand that, you'll need to do something very trivial, but also very useful for you as well, which is hover over the blue pins that you'll see. The blue pins are basically one of the more important pins in blueprints because the blue pins are basically objects. And if you hover over them, they're all not this. They're not. Yeah, whatever. If you hover over them, you'll notice that this is called sphere, which is, by the way, we'll get that in a little second. But if you hover over it, it's called static mesh component object reference. And then if I do this, if I hover over this one, and it says actor object reference. So technically now, if you connect it between the two, will it work? No. Why? Because this is a different type of object from where the function this is, if that makes sense. I think that was very not good explanation, but bear with me. This function does not exist in a something called in another class called static mesh component, right? But this function, set actor rotation, exists in a class called actor, which is, by the way, oh my god, it's the same class that we're working in, right? So technically this will work because I'm targeting self, and right now I'm in the blueprint graph of actor. However, if I grab, this is where grabbing is very important. I recommend this practice a lot. If I grab a wire from here and I say, okay, well, I can't set actor rotation with my sphere. How can I set the actor rotation? Well, you drag a wire, like I said, and then you say set world rotation or set rotation. Let's just do set rotation, just because sometimes you don't want to. Set rotation. Now you have set relative rotation, now you have set world rotation. But now it works. Now you are connected to this pin from this pin to another. Why? Is because this function exists in something called scene component. Now, what is a scene component? Here we go again, back to the class hierarchy. Scene component is a type of component that is from the object, that is inherited from the actor component, that contains its own set of functions that is for mutating your transfer. So your world, your scale, your rotation, okay? This is why the core class hierarchy is important to understand, because it helps you understanding, okay, well, I don't want this, I want that, right? In the future, you'll be working with a lot of different classes and you'll be like, okay, well, I want this function from this specific class. So I just want you to understand that from a perspective of object-oriented programming. OOP is not popular. A lot of hardcore programmers don't like it. And in the case of Unreal, it's going to be always in there. They're modifying a lot of things, but OOP is not the things that they're going to be modifying. I do want to solve one confusion because I just realized myself that I could confuse you guys, which is basically what the hell is a sphere? The sphere is basically what I'm going to be demonstrating right now. The sphere is, if you notice, Blueprint has like event graph, construction script, viewport. Then it has components here and my blueprint here, and then the details panel of every single vector. Let's go to the viewport. In this case, the viewport has something that you can see. Oh my God, now I can see my actor. Well, this is where you can start adding components, because actors are containers of components. Actors are basically nothing without components. So you need to add components to yourself to it. In this case, I just added a sphere, right? Well, I'm going to get a sphere. Okay. So now I have a sphere. I just added a component called sphere. Okay, well, I want to do some gameplay code. So I'm going to add an arrow as well. Okay. Here I am adding an arrow. There you go. Okay. Well, if you notice, if you hover over these, you'll notice that this is called add a component. This is called static mesh component. Just like what we saw here, which is if you hover over here. I mean, we can also reference things outside of the blueprint from the level. Doing gameplay code in the level blueprint is something that is a big no-no in general. Of course, you can do it for prototype, you can do it very quickly and whatnot, but I generally recommend avoiding level blueprints, especially for logics that you want to reuse here and there. You might want to like use level blueprints for like, I don't know, like let's say playing a certain kind of music, or like for event scripts and whatnot. But we'll talk about that a little bit as well. So yeah, so that's how you add components, right? So we've got the scene components and we've got all that stuff. But then also, what about a day or night cycle? So in this case, what you want to do is you want to actually create an actor called BP_day night cycle, and then implement that logic in there, and then place that actor in the world. What if you want to use it on different levels? What if you want to use it, or what if you want to have different versions of it, right? Imagine having to go to level blueprint and having to modify and having to copy paste it from one level blueprint to another. Like, what if you have different levels, right? So that's where it's like, it can be a bit insane. But do you put the directional lights inside the actors? No, because the directional light is actually itself an actor by itself. Now, what I would recommend is getting the actor itself. So you can get this. Get all actors of class, and then you can say directional light. There you go. Now I have it. Of course, you need to get the array. We'll talk about arrays in a little bit. And now you have the reference for the directional light. And now you can do whatever you want with directional light, right? You can do it that way. You can do it in other ways. I recommend doing it this way and avoiding level blueprints unless you're doing a very specific like trigger on the blueprints. Sorry, on the level that is non-existent in any other level. One of the biggest mistakes that I used to do when I first started out was I basically made everything, all the game inside the level blueprints. Then I realized, oh my God, how am I gonna scale it? I still finished the game. I still published it. It's still out there. It didn't affect too much. And that's why it's sometimes it's important, like, okay, well, I don't want to go fancy and be like, okay, I'm going to put it there. I'm just going to put it here. And that's sometimes okay. You don't have to like, that's one of the biggest mistakes with engineers as well, is that you have to use the latest, fanciest communication tech and all that and blah, blah, blah. Cool. Okay, so we're going to be, we're going to be talking about, that's cool. Ahmed, I think we should, let's, honestly, that sounds lovely. We'll do it in, I would love to have a conversation with you on that. I forgot what I want to say. Shit. No, you don't have to. You have to be sorry. That's completely normal. I love this. I love these interactions. I love these interactions. Although I have to squeeze everything in 30 minutes. Oh God. No pressure. Anyway. So what are we gonna do? What are we gonna do? Actually, so let me check my notes very quick. Oh, okay. So that's what I want to understand from object-oriented programming, OOP, and all of that. Okay. And the components. Sorry, the components as well. So the components, if you go back here in the class hierarchy, notice that there's something called actor component and the actor also scene component. Damn, okay. Well, these are scene components. Oh, this is actually scene component. Well, if you add actor component, you can also add actor components. We can add actor components by, let's say, I click on add, and then let's just find one with actor components. Let's go gameplay tag, something that I use a lot, for example. If you've noticed, actor components don't have any transform. So if I click on arrow, you'll see like, oh, I can manipulate it. Oh my God, right? It's a very cute arrow. But if I click on this, there's nothing. Well, this is why actor components exist. Actor components exist because they don't have transform. And then scene components are basically actor components, but you can manipulate them, but you can transfer them, but you can play around with these. It's an important concept in the future because once you become advanced in blueprints, once you become advanced in Unreal, you notice they're going to be putting a lot of logics inside those components and not inside the actor itself, which is like, it's like, okay, well, what's the purpose of the actor? Well, again, actors are just containers of the components. Very similar to Unity's way of things. It's a very composition-based, that's what we call it. Like it's a composition-based pattern. We compose our actors, our prefabs, our scene graphs, whatever engine it is, with components that have their own logics. And this is how you do it in Unreal. This is the equivalent of Unreal. Let's go a little bit over like just the UI of Unreal of viewpoints just very quickly before we jump into the next important demonstration, which is a tiny bit of a workshop, blueprint communicated. So this is how you create event graphs. What are graphs? Well, graphs, you don't have to worry too much about them. All you need to do is do everything in event graph, right? I recommend staying in event graph, unless you're doing something like a prototype graph. I do have in my games, sometimes I would say like a prototype graph, right? But I call prototype graph because I know that I will remove it in the future. I like to keep everything personally in event graph. Now, when it comes to styling and standards and like guides and all of that, there is a link, there is a slide in my slideshow, talk, guide, whatever, that references all this good standards, styling standards that you need in blueprints and a bunch of other things from different parties. And you can we'll talk about that a little bit. So that's what I recommend, just having prototype graph for a temporary basis. If you want to spend too much, and then just delete it at some point after you're done prototyping, right? And then migrate the logic into an event graph or into a component or whatever, right? Functions are functions. Everything that you're looking at is functions. I know Blueprints has like macros and event functions and all that. But technically, everything under the hood is functions. And guess what? You can create your own functions too. You create all your own functions by clicking on this little button and say, this, I like to start a standard function name with a verb. That's very important to know. Like, okay, make me cool Skyrim 2. Okay. And that's how you create a function. You can have a return on it. And then basically, why am I calling Skyrim 2? It should be like, I think the next one's Tamriel or whatever. Anyway, you'll have like basically inputs of it and outputs of it. You don't have to bother too much about this right now because you'll truly only learn and understand how to do it once you actually start. Once we actually start doing stuff with it, right? Like this is all like theory in essence, right? But this is how you kind of create one, right? But then I do want to focus on something called override. What is override? Override is basically you're overriding the function that your actor has inherited from. Remember how we, when we created an actor, we did like blueprint class and then we actor? Well, we do if our actor was in this component hierarchy that we saw, this is object, right? Technically, this is over here, GA underscore what? Sorry, PP underscore GA as in gaming academy actor, right? But technically it inherits from actor, meaning that all the functions that I have in actor is gonna exist in BPA underscore JA actor. That means you can override them. Override them can mean two different things. Override, which is a bit of a confusing name, but override can mean two different things. One of the first things is you can select any event you want, and then you click on hit. Let's say we want to click on hit, override hit event. You can now extend the logic of when your actor is hit by something. So now I can like, okay, well, when my actor is hit by, let's say, a bullet or whatever, I want to launch the character to the nearest point, or I want to make Skyrim 2, right? You're extending the logic now, right? Or you can do something completely different, which is overriding by itself, by basically doing this. I'm going to remove the parent hit. You'll notice that there's now like a new node, and by you can call the new node by doing this, like right click and add call to parent function. In Blueprint Assist, the plugin that I'm using, it does it automatically for you, which is why I love it so much. But like imagine like now you have to do it your own, but then you're like, okay, I don't want actually the logic of the actor. I want to do my own logic now, right? You can remove it, and now I'm overriding the logic. Now I'm overriding the logic and replacing it with mine. That's something I need to like. That's important to know. Macros, again, this is the kind of stuff where it's like it's better to in a workshop to understand how they work. But macros are basically functions, except macros have something like have the same abilities as the event graph. Because of functions, you actually can't have like things like delay or like move component, right? Delay or move component or timeline. You'll notice that all these stuff are basically, they have multiple execution wires at the end, which is very trivial because I just said like, there can only be one, right? Well, this is where it gets a little bit nitty-bitty, but this is what we call them as async tasks, or sorry, latent tasks. Async tasks are latent tasks. You don't have to really know exactly what they are, but they simply do not exist in the functions, and they can only exist in event graphs or macros. Okay, variables, we already talked about that. We'll through our little workshop, we'll talk a little bit about how to demonstrate the stuff, all these settings down here. Event dispatchers are a very powerful way of communicating between different blueprints. And they are well known for being something called callbacks. Callbacks are a common programming scheme that you can use basically everywhere, that is basically, used everywhere, that exists in the form of dispatcher, event dispatcher in blueprints. It's a very weird name to call it, but this is what it is. But we're going to demonstrate a way of using it, hopefully, in the workshop. And let's actually jump straight into it because we only have, I think, 20 minutes. I actually wanted to do a lot more stuff. Yeah, I was gonna do like a lot more stuff, but that's completely fine. Let's actually jump straight into the little tiny workshop, and I'm gonna now ask from you guys from the audience, let's any interactions, any interactions or any environment interactions, like enemy shooting you or a door or a door opening or sliding across something or whatever that you have in mind, suggest it. So that we can prototype. The reason we're doing it right now because I want to demonstrate something very important, which is blueprint communication. You have all these different classes and all these different things. How do you communicate them between each other? Well, I'm going to be demonstrating right now with a couple of different. If there's no suggestions, that's perfectly fine. I already have like 2 maybe in mind right now, just to demonstrate them. And it's going to be a little bit of improvisation, so I'm going to be doing a little bit of stuff on the spot. So if you guys have any suggestions on what kind of interactions we want, something that you want to do in the future as well, go ahead and suggest it. In the meantime, I shall create a new project for this. The reason why I want to create a new project because I actually want to submit it. I actually want to make this part of the. I want to demonstrate source code version control, which is something that is really badly needed in people who are starting out. Because what if you lose your work? What if the game crashes? What if your laptop crashes? Right? So I don't think we have enough time for that because I've noticed that maybe have maybe 30 minutes left. So we're just going to be straight away prototyping so we can demonstrate movement communication so that we can also demonstrate debugging. I'm going to start with the one suggestion. That suggestion is going to be an enemy shooting at you. That's it. Isn't that? Yeah, okay, let's do that. Or like something a little bit simple. Like when you step on something, something lights up. How about that? Something that a little bit easier. Fantastic. Let's do that. I do want to talk because, yeah, let's start with that. Okay. So we're gonna first create a blueprint vector. Well, what if we create? Okay. Unreal editor. All right, sorry, taking a bit of time here. If we don't have enough time, I will reserve 10 minutes just to shoot basically best practices and best how tips as well. Like from my original time. This is okay. All right, Unreal, come on, open up fast. All right, so I'm gonna come to the project creation. We're gonna click on games, and we're gonna go for a third person just because I won't have enough time to actually set up the entire movement and whatnot. So we're gonna use a template immediately and start to do the communication. The reason why I'm bringing this up though is for an important purpose. You'll notice that here you've got a bunch of settings, and this is one of the best practices or one of the tips that you can do. In blueprints or C++, remember that in C++, if you even choose C++, you can also add a blueprint class. And even if you choose blueprint, you can also add a C++ character at some C++ class at some point. So when you choose between the two, start with blueprint, later on add a C++. You can, by the way, this is not a lot of people know this, you can, by the way, like even if your project is blueprint and C++, you can actually remove the C++ stuff and make it blueprint only. There's a few steps for that, but if you're interested, DM me and I'll show you how. One more thing I want to say is when I say quality preset, I do recommend choosing scale because here's the thing. Well, with quality preset maximum, you got a bit of an issue. You already activating Lumen, nanite, ray tracing, specific occlusion, specific rendering features, and all that. You don't really need that from the start. You don't need that from prototyping start. You want to start with scalable because scalable will turn off all of these things and it will make it as sort of raw as it can humanly possibly be as in Unreal, right? The reason why I'm mentioning that is because you will notice, and I noticed this, I get a lot of questions sometimes. It's like, hey, why is this? Why is my PC performing bad? Why is this and that? Oh, well, it's because you're turning on all these features at the same time. Just turn them off, and then when you need them, turn them on one by one. Adjust the parameters so you can get the performance you want. So let's start with, so we'll do scalable. Let's call it GA session. Getting session. And I started content. Yeah, I don't know. We're gonna keep this as minimal as possible. I was hoping by the end of the workshop, we're gonna have like, I'm gonna show you how you guys can put it in Git as well, in version control, so that I could show you how easy it is. Like it takes like maybe 10 minutes max, and you don't really need to understand what you're doing. You just need to like a couple of patterns, and then voila, now you have track of your project. Now you can always like back up, and there's always gonna be a backup. You don't have to worry about ever losing work. I've lost a few projects just because I didn't have version control at the time. But it is what it is. Okay. All right. So blueprint communication. There are a couple of things that we need to talk about very importantly. Blueprint communications can come in the form of a couple of ways. One of them, casting. The other, called blueprint interface. Another, called dispatchers, or what we call them as callbacks, and what is known in C++ as delegates. Now, dispatchers actually require casting, but that's fine. Like, it's still a form of communication. We said blueprint interface, casting, dispatchers, and then my favorite, component fetching. I actually don't have a term for it. There's a term for it. I genuinely forgot what the term for it, but let's say fetching component. No, you're not fetching. Component-based communication. Let's call it that. Component-based communication, right? We're going to be demonstrating all four of them very quickly. So we're going to bring this project here, and we're going to start by creating a blueprint. So let's create a GA folder, GA session, and then we're going to say, hey, this is an actor that when I step on, it lights up. So interactable spotlight. Okay, cool. Well, I'm gonna first place the spotlight here, just so you can, because remember, actor is a class, and then you can instance it by just dragging and dropping. You can also do this by whatever the hell, sorry, by dragging the axis as well, by clicking on Alt and dragging the axis. Sorry, just to confirm. Be clear. Okay, so this first actor, let's call it, let's add a box collision, which is going to be our way of communicating and executing the functions, or our power plant of functions that, as we've talked about. And then we're going to add a spotlight. And that spotlight is going to be something that we have interacts with. You see a lot of these examples online, but I do want to emphasize on blueprint communication in these 10-15 minutes workshop, quick workshop. So let's say it has an intensity of 1,000. So if I compile right now, should see it here in my project, and it is great. Okay, cool. So let's start with the first form of communication. This is a pawn actor communication. So it goes vice versa, but the way you code your game blueprint right now is going to dictate which arrow is facing it right now. But this is an actor to pawn communication, which is arguably one of the easiest ways of communicating, because you can do something very powerful. Oh boy, I opened the other project. Okay, so remember when I said scene components that they have like their own like things and settings and whatnot? Well, guess what? You can also do something very interesting here. Because box is a collider, so we can constantly calculate collisions between that and whatever that interacts with it. It can be a hit or it can be an overlap. A hit is something that you hit, obviously, and overlap is something that you go through. In this case, we need to double check our collisions first. And we need to check something very important. So if we click on spotlight, if we click on box, you're going to have a bunch of settings in the details panel. You're going to scroll down. You're going to find, for example, something called collision. Now, collision can have presets. I'm preparing a talk at some point it talks a lot about performance collisions and whatnot. If you're interested, I can send you a DM on that at some point. But Collisions in this case, what we have them is overlap all dynamic, and we're already using a preset that Unreal does have, and this is exactly what we need. And what we need also importantly is to actually generate overlap events. So we make sure we click on that. Here's a bit of trivia, or here's a quick pro tip. You don't actually want this to be turned on if you have a lot of moving, overlapping actors, especially if your game is pretty dense and a lot of things going on. One of the flaws about Unreal is that this is actually a very expensive operation, especially if it's moving. And even worse, especially if this mesh that you have is a complex mesh. Ponder on that, keep that in mind in the future. I know like maybe it might not make sense, but that's fine. Because in the future, take a note now, and in the future, you will understand things. A couple of stuff. So in render, I'm just gonna unhide it so we can see it in debug. Okay. And I'm gonna compile, and I'm gonna also make it thick so I can see it. You know, like I want to see it. I want to see in the actual. I want to make sure that this is actually like not moving when it's not moving when it's on. Okay, so there's two ways to communicate this right now. There's event begin overlap, actor begin overlap. So we do that by right clicking, and then we type event begin overlap. Event actor begin overlap, sorry. Or you can do it another way, which is by right clicking on box. Oh wait, clicking on box, right click on it, and then click on add event, and then click on add on component begin overlap. They're basically the same thing. They're basically the same exact thing, right? However, let's say you have an actor, we have like multiple collisions, right? Like let's say you have a collision like on the head or on the arm or whatever, or on the head or torso or whatever. You'd want to use on begin component on begin overlap, just because on actor begin overlap, any of those events will fire on actor begin overlap technically. So this is an edge case if you have multiple boxes and you want to like I don't know, see a bullet if it goes through a box collider. Anyway, we want to say, hey, when a pawn is overlapping this component, which is the box, I want to do something. What is that thing? Well, I want to say set intensity to 0. Right? I want to turn off the light. Okay. So, like I said, what we do here is we grab it, and then we grab the function set intensity to 0. Now, you can technically do this, right? You can technically do this by right-clicking in an empty space and searching for intensity. But sometimes it can be buggy. Sometimes it fetches you the wrong components. Let's say if you have 2 spotlights, sometimes it can be a little bit tricky. So I would just recommend getting the variable component from the component list. You can also get it from here, from the component here. Get, and then search for the intensity. Okay. Well, if I do this now, if I connect these two, I don't have blueprint assist anymore in this case, and or electronic notes. So I'm going to be working with vanilla blueprints right now, which I hate, which is why you should get electronic notes and blueprint assist. Technically, if I have this function now, anything will go through. Anything that goes through the box will turn it off. We don't want that. We want that only to the player, only to the pawn. Well, how do we know that we want it only for the pawn, for example? Before I do, I want to demonstrate a very quick, cool debugging tool. So let's say you have another. How do we do this? What's the best way to do this? Okay, let me get the mods. Where's the mods? By the way, I didn't mention this, but we still use 4.27 Unreal Engine in our studio because we're working in VR, and 4.27 is actually more optimized for VR than it is from 5.3 and 5.4. Which is why I'm like sometimes like, where the hell is that thing is in 5.4? Because I'm still so used to 4.27. I know I'm way out of time. Anyway, so let's get the sphere. So we just place a sphere. Basically, you can do it by clicking on the blueprints here. You click on the icon here and then on the icon. We just want to make sure that it's overlapping all. So we click on collision, first collision, collision. Now I collision, and then collision preset. Let's go for overlap all dynamic. Maybe you want overlap all. Okay, overlap all. Okay. here's an interesting debugging tool. So let's say you want to like test a couple of things. You want to see like if the sphere is also turning off the light spotlight. What you can do is click on here, the three dots over here, and then click on simulate. Now, when you simulate, you can actually grab anything that you want. Where is the gizmo? Where are you, gizmo? The gizmo is the 3-axis thing. It's weird. Where are you? OMG, nothing's happening. Damn it. Unreal. Okay. Well, imagine there is a gizmo, and then what you can do is you can grab this and then make it go through the sphere, and then you will actually see the function actually running, even though you're simulating. You're not like actually running the game. You're actually literally simulating the game, right? Okay, that's one. Two, another debugging tool. You can use print string, do whatever you need to do in order to debug whatever things is happening. So print string, and then let's say here, other actor, you have multiple outputs, right? You have overlap component, other actor, other component, where body index from 3 to 3%. For every function that there is out there on Unreal, they have different unique outputs and inputs. I would always recommend going to the documentation, going through Google, say, write the function name, and then in the documentation, they will tell you what exactly these do. Alternatively, you can hover over these pins, and they will give you the values. Now, over time, the best way to learn this is over time, you'll just see like the differences and like you see what they do. That's the bit of a difficult thing compared to C++, is that in C++ you actually have these explanations. In Blueprint, sometimes you don't. It's a bit fuzzy. By the way, we got the other actor, which is basically the actor that has went through the box collision. And then we're just gonna drag it into the string itself. This automatically converted the actor from an actor to a string, meaning that it just got me the name of the actor in the actual game. That's what all it is. But it helps a lot in debugging. So I'm gonna go here. I'm gonna select the viewport. I'm gonna go through it. It's actually gonna probably turn off. There you go. But if you notice at the very top, top left, it actually printed third-person character, right? So this is one way of like debugging things out. Another cool thing you can do is you can right-click on the thing, right? You can right-click on any node that you need, and then click on something called double breakpoint. What is a breakpoint? From the word itself, breakpoint. Break the game for me. Not break it, but like stop the game for me. It's very commonly used in like a word that's used a lot in a lot of IDEs, right? But let's see what happens when I do a breakpoint, by the way. If I run through it, and bam, 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 now we have a breakpoint. Now what Unreal did is it's paused the entire blueprint for you, and not the entire blueprint, the entire game for you, and it basically zoomed you all the way to which the function has been called, which is fantastic if you ever need to like understand where things are coming from, if it's firing or not, or whatever the hell the reason why it might not be working. Now, this is two of the debugging tools that we have. I'm going to demonstrate more in the future. There's like 5 things that are like using a lot, but let's jump straight into the communication. If in this current state, if I do this, this will also turn off. Not right now, but this will also turn off because we're not familiar. So how do we make sure that we're also doing it? We're only doing it for the cast, for the pawn. Well, what you do is you grab an actor, and then you say something called cast. What is a cast? It is a very cool, very fun question that has been answered, or sorry, that's been like that's always going to be around programming for as long as programming exists. Cast is basically saying this actor that has just passed me or passed through me, can you cast it to the type pawn and see if that actor is a pawn? If it's true, we're gonna execute the function. If it's false, we're not gonna execute the function, which is turning off the light. The reason why everything's so implicit, like why can't I just know like this is already a pawn? This is where object-oriented programming that we've already discussed before comes in, and also polymorphism as well comes in. This is because everything is not known specifically, right? Like this is an actor that's been going through, not a pawn, not a thing. And the way to know that is by just hovering over other actor and knowing what type it is. It says actor object reference. There you go. Now you know. Well, now that if I cast it to pawn, now I will know that, hey, I need something else to demonstrate that it's not being triggered, but the gizmo is not working. So that's right. That's fine. That's fine. All right. So we're gonna now say like now it filtered out who's rolling board. Yeah, we can quickly. We can just we can quickly create a blueprint for it. Ahmad, this is where I'm gonna be using the level blueprint to do the stuff. There you go. Now we found an example for it. So we're gonna set simulate very quickly, and then physics, and then we're gonna add an arrow very quickly as well. And then we're gonna make this arrow appear. Just for quick for typing. Arrow. Where are you, arrow? Okay, cool. That's what I need. Okay, so we just added here, and then now we know where the arrow is going. And I grab this, put a level blueprint, and I'm gonna create a reference sphere, and then I'll then begin play. I shall get the arrow of it. And not get the arrow. Arrow, come on. Arrow. Okay, well, maybe let's be creating those. There's another way of communicating between blueprints, which is my favorite way, which we'll be talking about in a little bit. So, okay, get me the forward direction of this, and then and then add impulse, velocity impulse. Okay. And the impulse is basically like, hey, just impulse, like poop. Okay. So the forward vector, got a hatred for that blueprint. This is right, and times 300. Let's say times 4. Times float multiply. It's multiply times float. Let me float. It's different on Unreal 4. It's different. There's some bits where I like in Unreal 4 more than 5. Yeah. Okay. Now if I play, it went through the thing because it's not that was enable flexibility tools. Okay. We shall fix that real quick. So I think go to physics. Okay. Go to custom. Here. You don't have to really follow here. I'm just setting up so that you guys can get an idea of what I'm doing, or get an idea of communication, blueprint communication. So we're gonna go over object dynamic, and then go for physics, right? And then go for this, rounds, and then see what happens. We go, it should run now, and didn't. Why it did not? Oh, it's because everything's overlapped still. The only thing that I want to overlap is world time. Went to the other way. Fantastic, beautiful. Okay, good. Vector. All right. I bit of sidewalked over here, but there you go. Now it's overlapping, and it's not triggering the thing. But because I have cast it in pawn, it knows that this is the pawn. It knows that I will change the intent. I'll demonstrate it one more time. And whatnot. This is, by the way, the most simple way of communication, but it's also could be the the most detrimental to your code base and could be the most damaging. In this case, I like using it because I'm casting to pawn. And casting to pawn is sometimes fine. What is pawn, by the way? If you go back to class hierarchy very quick, we'll notice that look, pawn is part of actor, is inherited from actor, is inherited from object, right? And our third person character is actually a character class which is inherited by pawn, inherited from actor, and inherited from object, right? The reason why I'm okay with using this is because this is a good practice, because you're just casting to the pawn in a class external from the pawn. But the reason why I want to mention this is because I want to mention something very important. So I'm going to cast it to third person character. It's perfectly fine as well to cast it to third person character. The reason why I changed it to cast it to pawn is a bit of a trivia. You don't have to really know this right now, but will be good. Is that if you cast a pawn, you're reducing the overhead, the cost of using cast, because pawn is a native C++ cast. It is cheaper to use or to cast to than third person. Because third person character, you could have like effects in it. You could have like really cool but expensive skeletal mesh in it. And why is that even important? Well, every time you cast, you create something called a hard reference. And the hard reference is basically the kind of reference where hard reference is okay. Hard reference is basically saying, hey, every time I compile my blueprint, also double check if this class has changed. And if this class has changed, also compile it for me. Now imagine this class or this thing that you're casting to is big in terms of memory, literally in terms of memory. I'm talking like a skeletal mesh that's like maybe like 10 megabytes. That's just all gonna add to your memory, to memory budget, to compilation time, and to a bunch of other things. If you're interested to know, look into something called soft references versus hard references in blueprints. Again, something trivial for prototyping. You really have to really care about that right now. Now, I am getting sidewalked a lot right now just because I am low-key panicking about how little time we have left. This deserves another session. I would love to be interesting if we do another session at some point. Okay. What do we do next? All right, let's talk about another form of communication, which is get components by class, which is a much more powerful way of communicating. We're going to use a, sounds wonderful. All right, well, guys, I have a lot more tips going on. I have a lot more things I would like to mention, but we don't have the time, unfortunately. But feel free to DM, and I would be more than happy to talk to you about it and to demonstrate examples as well. I'm going to go through a couple of things very quickly right now. And there are three things that are super important in this blueprint communication. If you understand blueprint communication, you will understand how to prototype everything that you need. And once you understand that, yeah, you're good to go, true. But we're going to move away, diverge from that conversation, and just move to a very quick conversation so that we can just go through a couple of things. So resources, I'm going to move references, electronic notes, blueprint assist, samples, references. What I mean by samples, Epic Games and sometimes other third-party games release their own references or sample projects in order for you to study them, understand them, see how you want. My three favorite ones are, and they are complex, but they are very powerful and they can be detrimental to your understanding, is something called LiDAR project, something called crop out project, something called content example project. LiDAR project is great if you want to do anything multiplayer, something that is complex in terms of mechanics, something that is modular and scalable and whatnot. Maybe if you're starting out, you don't really have to like look into it like the first year ahead, but in the second year and the third year, it's important to know. It also contains a lot of good practices like common UI and enhanced input context and all that stuff that I would love to talk about at some point. and they have a lot of those nonlinear bits, tricks, and whatnot. But today we just went super basic on the surface. Crapout is actually going to be very good for your purposes if you're starting out. Crapout has a lot of like data-driven way of doing things, and this is also for mobile. Even though I know we're not making a mobile game, but usually when you're starting in mobile, you're doing things a little bit easier. Everything is a little bit more simpler when it comes to like code base, when it comes to like implementations and plugins. Content examples are the holy grail of sample projects. Content example basically contains everything and different stuff. Blueprint communication. There is literally a content example level or levels. They demonstrate basically in every topic that you need in Niagara, in blueprint communication, in materials, in math materials, and physics animation, all of that. They have all these demonstrations. I would highly recommend going in there and just basically go full out on like that. I've learned a ton from that. I want to talk about a little bit as well, tool resources. I'll be sharing the slides there, but let's go very quickly here. These links are basically links to the things that resources that you need. General is basically what you need to basically understand from an Unreal general point structure, right? And I recommend basically following that link and understanding. Multiplayer. If you're making a multiplayer game, I would recommend, if you're just starting out in Blueprints and you're starting out in Unreal, I would refrain from making a multiplayer game. But if you're not starting out, like maybe this is your second, third year, let's say, start looking into, if you want to make a multiplayer, start looking into multiplayer. And this is my my 3 resources go-to for multiplayer replication, because multiplayer in Unreal is handled a lot by Unreal, by packet managing, by serialization, by all that. All you gotta do is something you call, you gotta just replicate the properties, or like synchronize the different variables from one client to the server, to the client, to all of that. And this 3 resources give you that resource that you need. Shaders. I love shaders. I was gonna demonstrate some shaders math and all that cute stuff with shaders today. Shaders is one of my favorite things to do. They can be very powerful, and in Unreal specifically, they're even more powerful because they have a native solution of like an edit material editor. We were going to go through these notes, but that's perfectly fine. We can go through them at some other time. And for that resources, I would recommend basically going to this beautiful person, amazing person called Ben Cloward. And he's been doing shaders for the last 20 years, and he has basically like 200 videos going over every single basics of Unreal. Yusuf, if you're scared of shaders, this is great for you. They have Unity. He has Unity, and he has Unreal. I highly recommend that. Yes, Ben is fantastic. There you go. Adding knew how to make a water. I knew how to make a couple of parallel effects, so I highly recommend, if you ever need watershed, ever need like any help, go there. Understand the basics of shader. We'll teach you. Niagara. Niagara is a little bit of an interesting one. Niagara is something, the kind of system where you actually can do a lot just by reading documentation and just by understanding how things work. Because Niagara, a 30-second crash course by Niagara is made up of modules. What are modules? Modules are basically different behaviors that you can do in order to create the behavior that you need. So this is Niagara. I know it's got a weirdly looking editor again, but they're all made of modules, and every module has its own purpose, and so much modules has been built for you. So free documentation, go ahead, experiment. You'll get crazy good results very quickly. That's why Niagara is loved. Not loved in 4.27. I hate Niagara in 4.27. It crashes all the time. I want to switch to 5.4. I don't have the time for it. What else? C++. Okay, C++ is an interesting one. If you want to learn more C++, text me. But also, here's a quick guide on that. Tom Lumen Unreal Engine CPP guide. And finally, yes, shaders are the same in UE4 and UE5. Yes, like that's the beautiful thing, is that the shaders when Ben Cloud, you can transfer the knowledge from Unity to Unreal and vice versa, and Godot as well. And everything is HLSL or GLSL code as well. So technically, everything can be written down into literally just code if you don't like node shaders. Okay, and the last resource that I have, I call it the holy grail of understanding Unreal Engine, and it has helped me a ton in understanding Unreal Engine from its core all the way to the very top, which is blueprints. Blueprints is considered a very top level, high level tool. This is the link for it. Take your time on it. It needs a lot of patience to understand what's going on there. Style guide. I know what you're thinking. Okay, why do you need a style guide? Well, style guide is just putting the standard for naming conventions, for naming your functions, naming your assets, naming everything you do in the game. And there's a couple of things going on. And my purpose, and my recommendation, my personal recommendation out of my experience is that I would recommend reading all these standards and then do your own, merge it together, do whatever you think that feels best and looks best. But one thing you need to do is that you need to keep that standard from the beginning of the project till the end of the project. That's the most important bit. Here's 4 or 5 resources that you can go into and read how they've done their own standard, their style guide. Look into that, see what feels good. I like splash damage a lot. I like other UE5 style guide a lot too. So version control resources. I was gonna do in this talk when we're done with the blueprint communication. I was actually gonna push this. I love you too, Kutub. I was actually gonna push this into. I want to demonstrate on the hand, on the spot, pushing this to version control. I'm sure some of you already know this stuff, but yeah, it's very easy. It's very straightforward. Text me if you need any help on that. But here's a basic way, basic resources of how to do it. They don't really demonstrate it. These are just the tools for you to actually set up the version control. AngelScript, what the hell is that? AngelScript is basically a third-party scripting language. You don't like blueprints? That's fine. You find C++ too hard? That's fine. AngelScript comes in the middle, right in the middle. And AngelScript, if you notice the link, it's called angelscript.hazelight. Who's Hazelight? If you guys know, Hazelight is the people who made it makes every time I forgot the name of the game. It takes two. I forgot. It's the one game of the year award, the game awards in 2021, I think, or 2022. It Takes Two. Yes, It Takes Two. Yes, these guys. Yes, these guys have ported AngelScript into their own game, and it works. And it's amazing. If you don't like blueprints, fine. Don't worry about it. You like C# more? That's more closest to you. If you don't like C++ and references and all that ugly stuff and ugly syntax, also fine. Go to AngelScript. We love it. And one more thing I would like to mention as well is stay updated with the latest on Unreal. And there is a public roadmap that you can go into with this link to follow what they're doing and what they're going to be doing next. There is a lot. And I'm telling you, it's overwhelming, but do not fear the course of changes of things by having to constantly update your tech, constantly update your code to the fanciest stuff. There's going to be a lot. They're going to be pushing a lot. But yeah, it's good to know what's happening in Unreal, what's going to happen in Unreal and whatnot. This is the public roadmap for it. One more thing, hot tips. Hot tips, I was going to merge it with a mix of our workshop at the end. We would have a very nice demonstration of things. But I'm just going to do hot tips now. I don't know, hot tips is our title. Anyway, I'm going to do tips now without the context. So bear with me. We're going to be, it's fine. So there's editor hot tips, read directories. Just remember that every time you fix three directories, when I say fix directories, I mean move one asset to another, right? Just make sure that when you're done, you right click on this, you click on fix update redirectories references. This will fix up your references and this will stop from certain assets being corrupted. You have to be careful because, for example, in Fortnite or in Epic Games, what they do, they actually fix the redirectories by the beginning of each holiday when everyone's out of office, right? But in your case, you're doing it by yourself or doing it with a small team. So having any corrupted assets is unlikely because you're fixed up your directories. But yeah, just keep that in mind. Always make sure, always clean up your redirectories. You can find all the project game editor and the engine settings in your config. You can modify them straight through text. You don't have to do it through the editor. Let's say one day your project isn't starting out because of one project setting. You can modify the text project setting, which is found in your folder config. That's another one. Play where camera editor position is. So let's just do a very quick demonstration. If you click on here and then click on current camera location, click on that, and then bam, you can play. Now you're playing and where the camera is, right? It's helpful. It's very nice. And on Unreal 4.27, and it was very on Unreal 4, it was actually very weird, but now they fixed it. Thank God. When you're comfortable with blueprints, look into editor utility widgets. They're very, very powerful. I'm not going to go further into that because we don't have time, but they're very, very powerful. Look into that once you're familiar with yourself with blueprints. Finding blueprints, which is a tool. You can go here, and then you say find blueprints, and then whatever function you have thought or you have in mind, you will find it here. So here we go. Now it's querying the entire contrast. It's very helpful. Okay. Rendering, keep your textures to the power of 2. It's very good to keep it 256 by 256, or let's say 10, or let's say 1024 by 5 times. Just keep the power of 2. It's very helpful. Unreal needs it. Unreal needs it for you to optimize, for them to optimize your memory. You know how like you sometimes you play around with Unreal and then you get streaming memory over like blah 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 1000 megabyte. Well, if you do mipmaps correctly by doing the power of 2, you will never, hopefully never, have this problem. And I don't have textures to demonstrate it right now, but there's one tool you can do, which is if you go to Tools, you go to Audit, you go to Asked Audit. Sorry, not Asked Audit. Shit. You go to Statistics. You will find basically what the textures are, what they're using in terms of size. Where is it? That's because there's probably no textures, but you will find textures like here. You will find textures and how big they are using this tool, and you can track that in order to see how big and how small your texture is. You can there's a texture editor tool that you can use that minimize that you can reduce the texture size as well. If you're using a lot of lighting, especially if you're using dynamic lighting, minimize it. Just keep it down. Keep it as much as possible down. Right? You want to keep your performance as much as possible. Another thing is avoid placing translucent surfaces on top of each other. Again, this would have made more sense with the context when we go through materials, but we didn't. That's perfectly fine. Just if you select material translucency and put them on top of each other, avoid that. You can do it at some point, multiple surfaces, but avoid having like 50 on top of each other. You will break your performance. And then finally, another one that's out of the context as well, which is create the hierarchical and synthetic meshes. When you have like, let's say you have like 50 type of rocks, 2 rocks, they're all the same rock, they're all the same static mesh, but they're all separate. You can use something called hierarchical and synthetic meshes to combine them in one. And when you do that, you combine everything in one draw call, and then you reduce a lot of performance overhead. You're improving your performance. In VR, I personally because we're doing a game and applying in a 1-to-1 New York City scale, we do a lot of optimizations. And this is one of the things that we do a lot in order to make sure performance is good. This is it. That's it. Thank you so much for having. I know it took a long time. Unfortunately enough, I didn't cover everything, but that's perfectly fine. You can find me on my socials. You can find me everywhere. You can email me if you want, and I will share slides only because we don't really have a source code right now. I will share the slides only later, but I will always try to share the source code, maybe a demonstration or two as well. Thank you so much for having me, and best of luck. If you have any questions, do send them over.